Let's look at some trends. And these are trends actually published by the Council on Tall Buildings and Urban Habitat. And what you can see here is that 1.4, so this is by UNESCO, 1.4 billion people will be moving into cities by 2030. That's an incredible amount, and it has been talked about quite often here during the conference. It has a lot of consequences. Cities have to go higher, cities have to get more intelligent. From the Council, we can see that the number of high-rise buildings are actually exploding at this moment. They are really increasing exponentially. We can see that the light blue buildings over 200 meters are just really exponential in growth, and so are the buildings over 300 meters, the dark blue. These are statistics of the Council. Now, as these buildings get higher and as these cities get more dense, they have to become more intelligent. And that brings me to my first topic, people flow intelligence. What is an intelligent building? For me, it's actually a very simple answer. Complying with the customer needs, meaning with the users, and complying with the needs of the owners. We have to comply with both of them. If you comply with both, you have a damn intelligent building doing what they want. And that's what it is. It's very simple, complying with their needs. Now, if you look at what I call the moving blocks, we as an elevator company produce entrances, doors, elevators, escalators. We pride ourselves of people flow. I can't see people flow here. I really have to look at all the moving blocks in a building. I have to look at every single part of the journey, from the outside of the building all the way to the last door visited. And every one of those phases has to be optimized. Not just elevators, not just escalators, every single one of those have to be optimized to meet with the needs of the customer. That's from the user's point of view. But we also have the owner's point of view. And what is the world of the owner? The world of the owner is the following. He has a hell of a lot of subsystems, an incredible amount of subsystems, which he has to actually integrate as much as possible to do the optimum for his users. And it's an incredibly heavy task. Integrating of intelligent systems is very heavy. All those systems can be intelligent on themselves, but they are hardly ever very well integrated. And it's an incredible job for most of the building owners. It's one of the heaviest tasks they have. And it's very often done particularly bad. It can be done a lot better. So we at KONE started looking at how can we optimize those parts of the subsystems that have to do with people flow. And those we have now put here. We have elevators, escalators, and automatic doors, and we actually put them with the people flow systems, which are access, destination, information, and monitoring. We've added that as an integrated system where you don't need to think anymore about integrating those subsystems. From one provider, you can get all. And by the way, we've just added a while ago also turnstiles to this list. So you can also get KONE turnstiles directly from us, integrated into these same systems. And then, once you have this, it's quite easy to integrate it to the rest of this building through, for example, OPC servers. And we can have all the systems more or less integrated in a nice way. But this was the first step, integrating people flow movement in the building, people flow systems in the building. And we call this system people flow intelligence. It's coming up slowly. Okay, there it is. And monitoring and information, I'm not going to talk too much about. It has been there a long time. We have integrated that even further. With our monitoring, you could do multiple buildings, really incredibly big complexes together. And now we can actually expand that further to access and destination. Let's look at access. Yeah, so access control. We again looked at the people flow part of access control. From the door, the entrance, to the lobby for example, at turnstiles, destination operation panels, even mobile devices, and in the car, the elevator car, and, of course, at your office floor. That's the people flow part. So we came out with KONE Access, which handles that people flow part of your business. If you want to expand to the operational part of your access control, time management, you name it, whatever you want to do, the organizational part, that actually comes in very, very late in the construction phase when the users are actually known and come in with their own systems. We can, of course, integrate directly with one of our partners, and then the system is fully integrated already, nothing to reintegrate. It fully works immediately. If we have a company with multiple access systems through the building, it's pretty easy through XML to then integrate the databases and to make sure that we have an integrated database. Another possibility is, of course, that you have only one database. And that requires quite a lot. If it's the owner's database, that requires, interfacing to third-party security access. We can also do that for you. But there is a difference. Let me show you that. If you take KONE Access, you get everything integrated as one unit. You have, all the devices designed to look the same, designed to operate the same, designed in one single integrated system. Everything works from day one, and it works without your having a headache. If you do third-party integration, what you get from us is a bunch of papers which you then have to work with to integrate the system. It is not an impossible job. It's been done quite a lot, but it requires a lot more work for you and some software writing. And by the way, very often you will have situations where you're going to be dependent on the access control company's speed. So you can have some inconsistencies in how fast the systems respond, completely not depending of the elevator company. With Access, KONE Access, that is out of the equation, and everything works as fast as possible. Okay, let's take us to destination control, because that is where we use a lot of access as well, but we also use it in conventional control. So let's look at destination. We have two systems. We have the traditional DCS system, where we have the destination operation panels on all floor. You give your destination outside, and based on the traffic and the traffic situations, the system then optimizes what it has to do, as explained, for example, by our previous speaker. But then we also have the hybrid system, a system where we can mix the full destination system with the old world, the normal buttons. We have guests and we have users who hate destinations, but we have users who love destination. We give everybody what they want. Yeah, we make it possible that select what you want and allow that. What we typically have with hybrid destination is that we have the destination panels on heavily used floors. And it can be multiple floors, heavy used floors. That's what we typically do. And then on the other floors, we can have normal buttons, and I'll explain you just why we do that. But we also have now a system now, coming out with a system now, where we can actually put destination operation panels also on the other floors, touch screens on the other floors, and they work in principle like buttons, but guiding you to the other floor. You can't do multiple floors there and double pushing anymore. That's impossible now with this system. So with this, we can then optimize the system further. I'm going to show you what that actually does. If you have traffic away from a heavy floor, meaning you have that big arrow, that thick arrow at the bottom of your building going up, for example, you have a lot of people entering their calls there. You know where they're going to go. That's an extremely predictable situation. You can predict exactly what's going to happen. And this is a situation where you can optimize by putting people to the same destination in the same car or doing other things which you need to do to serve them in the best optimal way. This is predictable. The use of destination operation panel here is extremely efficient. Extremely efficient. But if traffic is towards a heavily used floor, for example, to a restaurant floor, which is very, very heavy, The other traffic is quite sporadic on the other floors. It is not that often. And predictability really starts suffering. Now, with destination control, if you make your decision immediately, sorry about that, can't change anymore. That's it, yeah? So that becomes an issue, and you get some inefficiencies in there. So what we have done is we have added, for example, a button system, or now even a touchscreen system, where you can actually now give your call, and it will tell you use the next elevator coming in your direction. Yeah. So in that way, we can then still optimize the system in such a way that we can actually reallocate the system as long as we can in those difficult situations to optimize the traffic, and it always comes out better than where we have to do very difficult situations. You get actually this. If you look at the conventional system, it is there a? There's nothing here. When you use a conventional system, you can see that up peak is actually pretty lousy with the conventional system. You can't do much intelligence. You have to drop off the people in sequence of calls made inside the car. You can hardly use any intelligence. All you can do is prevent bunching. That's all you can do practically. So not a great system there. But for lunchtime, it's fantastic. You can really use a lot of algorithms to make that as optimum as possible. Yeah, so it really starts boosting. Same with down peak. You can really use a lot of algorithms to make it work. If you look at traditional DCS, it is actually fantastic in up peak. That's exactly what it's made for. It's really fantastic in up peak. In lunchtime, it works, but you have a situation here where the unpredictability causes quite a lot of problems, and you actually have to use incredible intelligences, and you still don't get there because of the problem with the predictability. So I give it a little bit smaller dot. In down peak, you actually have to add a hell of a lot of intelligence. Otherwise, the system will not be able to limit the number of calls based on the situation. So you have to add extra intelligence there before it works. And therefore, I've not given it a very good rate for down peak. If you do a hybrid system, you actually get the following. We try to optimize every single situation and get it as good as possible in every single situation. So that is hybrid destination. Let's get to the input devices. This is our new input device, our new touchscreen. Very good looking device. We have won several awards already for the design. And for example, the Red Dot Award, which is a pretty big honor in the world. It's made of real materials, glass and metals, easy to clean. We have the user interface, the floors, etc., on one side, on the left-hand side, and the other options on the right-hand side. Yeah, so easily findable for people with disabilities. We have the tactile, which is reminded by the codes. We have the backplate there, which actually makes it float away from the wall and makes it, the interface to the wall. Even if the wall is rough, it makes it very, very easy. And you don't see some these rough edges around which you can see, for example, with flush-mounted systems. So this hides all of these inconsistencies. It's black with white. There is no better contrast than black and white. It works under every single condition. And the size is 30 by 30, easily findable. Works perfectly right with the architecture of your lobby where you have vertical lines in your architecture. So it works perfectly right, that square, with your architecture as well. We have 4 user interfaces. The list where you select. This is very nice, for example, in hotels. Rooms, the lobby or the reception, bars, Sky bar, whatever, you just press and then you can continue again. So a very simple, usable system. You can have the slider, where you just move your finger up and down, put it on the ball, move it. It's just intuitive. You know how to use it. You don't need an instruction, and it works for whatever culture. The keypad version, which can also be selective, so that if you are not allowed to push a button, it's not visible, or it just doesn't show up very bright. And then we have the direct call. In many offices, we don't have a lot of floors. And then we can have all the floors with a single touch and go system. So we have 4 different interfaces to make your life as easy as possible again. We have really looked at the usability of this device. Last but not least here. Your mobile phone can be your call device for elevators. Call the elevators directly from your mobile. Yeah? And it works with both iOS and Android at the moment. So 90% of all phones it works with. You only have to give the floor where you are. It's like calling a taxi. Tell you where you are. Tell where you're going. It then allocates a car to you. It comes there. You can follow it. And you see when it arrives. Yeah? So practically the same way as a taxi. Calling a taxi, more or less. Directly from your phone. But that gives us a hell of a lot of other possibilities in the future. Now it's software. Now, and it's in your pocket. You are in constant contact with the elevator all the time. So the elevator system can do much more intelligent things in the future because you still have contact. Instead of walking away from your destination operation panel, you have it in your hands. So it gives you an opportunity to really future-proof the future. Here we have it, for example, in our headquarters in Finland, our KONE headquarters. It's there in the reception. In the reception, it's fixed on one floor. Now, all we need to do is fix that floor where the destination panel is. So we have remote call with fixed floor. And all you need to do now is give the call. Select your destination, and you get there. Yes, it tells you which elevator to use. And Mr. So-and-so, can I send your guest up? Yes, please, do it. In hotels, this is fantastic. All these kind of places, really fantastic. What else can you do with it? You can use it for receptionists. You can use it as a wireless DOP. Yeah, a wireless destination operation panel. You can use it, for example, in our hybrid. Want to try out as a new customer how destination feels for you? Is it your thing? Put it on the landing. And now, all of a sudden, you have destination control. Yes, and you can try it. You can put them any place and try out, is that the right position for you? Have a special event? Don't have destination panels there? Just add a couple, and you can hold your party there. Now you have a very efficient party where you can really move the people in the right way. In modernizations, put on your overlay. Put on your overlay. That's done in the background. You don't even notice it. The next day, all the DOPs are on the floor, and you have full capacity of destination control. Yes, a very, very fast overlay, and we can then take and start assembling it as we go. But you have the maximum capacity overnight. A very, very fast overlay. That brings me to the next topic. This was people flow intelligence. But those buildings don't only need to get intelligent. As they get higher, we also see problems with the roping system. Ropes actually need to carry ropes. The rope weight grows exponentially with height. And I'll show you that a little bit later. It's very, 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 very drastic how rope weight grows. And this actually made the elevator the bottleneck. 500, 550 meters, that's about the limit. And then it really starts getting ugly, very ugly. So what is ultra rope? Ultra rope is a very lightweight rope. It's extremely light. It's 1/5 of the weight. But if you get the effect of needing ropes to carry ropes as you go higher, that difference can go to 1/10 or 1/20 of the weight of steel ropes. Ultra rope is extremely durable. Ultra rope can be bent over rather small radius. It is extremely durable. In principle, carbon fiber is very hard to fatigue. It's actually the coat that is the only wearing part. Yeah, so it's extremely durable. By the way, it takes reverse bends pretty well as well. How is it built? We have carbon fibers in the longitudinal direction held together with an epoxy matrix. And that gives it very high strength, very high E modulus, and excellent bending fatigue resistance. It's also inert to low and high temperatures. It's a fantastic material. It's actually used everywhere where you need performance and lightweight. That's where you use it. Racing industry, whatever you need it for, light airplane industry, car industry, that is where it is used when you need performance and lightweight together. The coat is there to create the friction and to hold all the 4 bars together. It bonds very well with the epoxy matrix. This is your problem. As you go higher, this is about a 2,000 kilogram elevator. As you go higher, the total moving masses just grow exponentially, and it's mainly because of ropes. Mainly because of ropes. At 500 meters, it can already be about 60% of your total moving mass, just ropes. So it is incredible. With ultra rope, you don't have that effect because that is so light that you don't get that effect of needing ropes to carry ropes. And it only grows gradually with the height. The difference grows tremendously big. And you don't need to move all that mass around anymore, which means that also your energy consumption grows quite fast with the height. At about 500 meters, we are talking about 15% reduction in energy consumption. At 700 meters, that would be about 35-40% compared to already extremely efficient regenerating energy consumption from our present machines and permanent magnet motors. Another big advantage of ultra rope, it is so light, so the frequency of the rope is much higher than the frequency of steel ropes. It will not coincide with the building frequencies anymore. And that actually is a very nice thing because it makes it a lot less sensitive to building sway. You still have to look at the shape of the building, of course, but it is not anymore a resonance problem for you. So it takes quite a lot of the resonance issues away. You actually need to get to somewhere 800 meters before you finally start getting similar resonance features. And by the way, even then you can add extra weight because the ropes are so damn light, you have saved so much weight already. So there are ways to getting around it quite easily. This is for the Kingdom Tower. I'm going to show you what it does on the Kingdom Tower. We were fortunate to get that order. The travel is 634 meters high for the observation deck elevators. They are double decks, 2 times 1600 kg. The rope weight with 300 TX rope, by the way, that is super high strength steel ropes. That is not just a normal steel rope. That's your super high strength steel ropes. Is no less than 20,365 kilos. With ultra rope, this is less than 3,000 kilos. That's an incredible saving in weight that you don't need to move around. The total suspended mass is 46,340 with the double deck, and with the ultra rope, it's only 29,000 kilos. So it also reduces your sheave shaft load and makes the life of your machines much bigger. Current, it has a tremendous effect on your main fuse size. Look at that. With steel ropes, you are between 500 and 630 amp, depending on the speed you want to put there. And with ultra rope, you're at 400 amps. Just imagine those risers, 2 kilometers of 3 cables going all the way up. Yeah, 3 risers going all the way up, 2 kilometers, reducing your copper need quite dramatically. That's tens of thousands of euros just for the risers only, plus the whole electrification system behind it. Look at the energy consumption reduction. At 10 meters per second, 16%. At 12.5 meters per second, 20%. That is dramatic. It has other benefits. Your structural loads are reduced. It can work down all the way to your foundation. It has a big effect. The copper, as I stated earlier, is quite a lot reduced. All that energy reduction is less loss of energy which you have to remove from your building. So also your cooling requirements are a lot less immediately. Life cycle benefits is the energy consumption is so low compared to what it was earlier. And the availability, ultra rope lasts at least twice, sometimes even 5 times longer when you look at super travels. Because in super travels, we have to reduce the safety factor to compensate that extra weight on weight. Yeah? It just becomes an undoable equation. And this also has a very good effect. Then the fact that you don't have to look at that carefully anymore at sway. It is much easier with sway. All these effects are very big benefits for our consumers, for our users, for the owners. These are very big changes. And I've not even told you half of the benefits which you have with KONE Ultra Rope. So please come to our stand. We can talk about that a little bit more. And we can really go into the details there. You know, Marina Bay Sands, we installed it in September 2013. And we have an absolute perfect opportunity to compare ultra rope with conventional rope. We took 3,000 kilos of rope away. 3,000 kilos. That's not a small bit, which we don't need to move around anymore. And We have found until now, when we compare it with similar runs, elevators, we have about 20% reduction in a normal height building. So the values which I used earlier were actually a little bit on the conservative side. In Marina Bay Sands, where we have a lot of starts, each time you need to accelerate, this is where it makes a big difference. We have 20% reduction in energy consumption. That is big. This technology will help us in the future to future-proof your building. Computer systems you can update. This rope technology is the next step to make it possible to go higher and to make the energy even more, energy of your building even more efficient. So this is what I have to present. Thank you very much.